Hey guys, again this is your cloud mentor, Girish on Effort. Today we are dealing with the power. We will discuss it in the sense of physics. So let's move on. Okay, our objectives of this video are to apply the relationship between average power, the work done by a force, and the time interval in which that work is done. And when given the work as a function of time, find the instantaneous power. Also, to determine the instantaneous power by taking a dot product of the force vector, and an object's velocity vector, in magnitude angle, and unit vector notations. So, power. The time rate at which work is done by a force, is said to be the power due to the force. If a force does an amount of work W, in an amount of time delta t, the average power due to the force during that time interval is work upon that interval of time. That is, P equals work divided by time interval. The instantaneous power P, is the instantaneous time rate of doing work, which we can write as P equals dW divided by dt. Suppose we know the work done by a force as a function of time. Then to get the instantaneous power at, say, time t equals 3 seconds during the work, we would first take the time derivative of work, and then evaluate the result for t equals 3 seconds. The SI unit of power is the joule per second. This unit is used so often that it has a special name, the watt, after James Watt, who greatly improved the rate at which steam engines could do work. In the British system, the unit of power is the foot-pound per second. Often the horsepower is used. Perhaps because they appear on our utility bills, the watt and the kilowatt-hour have become identified as electrical units. They can be used equally well as units for other examples of power and energy. Thus, if you pick up a book from the floor and put it on a tabletop, you are free to report the work that you have done as, say, 4 into 10 raised to 6 kilowatts-hour. We can also express the rate at which a force does work on a particle, or particle-like object, in terms of that force, and the particle's velocity. For a particle that is moving along a straight line, say, an x-axis, and is acted on by a constant force directed at some angle f to that line, equation becomes P equals dW divided by dt, to F cos phi divided by dt, as work is the dot product of force and displacement. It can be further rearranged to F cos phi dx by dt. And finally, we get an equation, P equals Fv cos phi. That is P equals Fv. For example, the truck in figure exerts a force on the trailing load, which has velocity at some instant. The instantaneous power due to force is the rate at which force does work on the load at that instant, and is given by the above equations. Saying that this power is the power of the truck is often acceptable, but keep in mind what is meant. Power is the rate at which the applied force does work. Now let's have a look at one previous JE question. A 60 horsepower electric motor lifts an elevator with a maximum total load capacity of 2,000 kilograms. If the frictional force on the elevator is 4,000 Newton, the speed of the elevator at full load is close to A. 1.9 meters per second, B. 1.7 meters per second, C. 2 meters per second, D. 1.5 meters per second. So here we have a lift which is moving upward. It has a total load capacity of 2,000 kilograms. And as it is moving upwards, there acts a frictional force downwards. And given the frictional force is 4,000 Newton. Now if the lift moves upward, it should produce a force which is equal to the net force created by the weight of full load, and also the frictional force. The weight of the load will be multiple of mass, and acceleration due to gravity. Taking g as 10, we get the weight 20,000 Newton. And now adding it with frictional force, to get the net force acting downwards. So total, we get it as 24,000 Newton. Now we have an equation, P equals Fv. From this equation, we can find the speed v and the power of the lift is given, 60 horsepower. which is equal to 60 multiplied by 746 watts. And now the velocity will be, power upon force, that is 60 into 746, divided by 24,000. So the answer is 1.86 meters per second, which is near to option A.
Hope you guys understood the topic. Thanks for watching my video. Always be free to ask questions. Subscribe to my channel for more videos. If you like this video, share it with your friends. See you guys.